In this lesson, we will discuss pressure in General Physics 1, Module 5 or Week 5. So, first, we will define first what is pressure. So, pressure in layman's term is the push on the surface created by one or more forces. So, basically, force is like something that you push or something you exert force towards that object. And we can say that pressure is an effect that force produces of an object. So pressure is like applying force to that object which you are creating pressure to it. Before we proceed to the next slides or through the discussion, we will watch first a video which discusses furthermore about what is pressure. So this video will elaborately discuss what is pressure.
My name is Carlos Villa, and welcome to the National Mag Lab. Right now we're going to talk about pressure. This is a balloon, and the reason that balloons stay inflated is because there's air inside the balloon that is pushing against the walls of the balloon. At the same time, the air outside of the balloon is pushing on the inside of this balloon. So this balloon stays at this size because the pressure is pushing out and the air inside is pushing this way, so this balloon stays this size. Now, if we remove the pressure on the outside of the balloon, the air inside it will be pushing harder than the air around it, so the balloon will actually expand. And we can do that by taking the balloons and putting them inside this vacuum chamber. When I turn this on, this pump is going to pull all the air out of this container. So there will be no air to push against these balloons. And because of that, they're going to expand because the pressure inside is going to be greater than the pressure outside. You can see them shrinking down to their normal size as the air slowly goes back into the pump. Try that again. Now if these balloons pop, you won't hear very much because sound does not travel in a vacuum.
So after watching the video, we will now proceed in what is the formula in finding the pressure. So this is the formula in finding the pressure. We will write it on a piece of paper. So the formula in finding the pressure is P is equal to F, which is the normal force, over A, which is the area acting per unit. To fully understand the principle of pressure, we have here a sample. So this is our first example. The sole of a boat has a total area of 0.028 meters squared. Then a 55 kilogram person is wearing these boots and takes a step on 1 foot. So we have our given, which is 0.028 meter, which is the area of the boot. Then the weight of the person the weight of the person is 55 kilograms. So this is our given. Since we have our given to the problem, we need to calculate first the weight of the person. So in calculating the weight of the person, we have this formula. Is equal to W is equal to mass times G, which is the gravity. So the mass here is 55 kilograms. 55 kilograms. And the G is 9.8, which we will use another unit, which is the N over EG. This is also similar with 9.8 meter per second squared. It's also similar. And next, we will cancel the EG. Then we have here 55 times 9.8. So we need to multiply these two figures. So we can get 539 Newton. So since we have our weight, we will use this weight in calculating the next problem, which is calculating the pressure. So I'm gonna paste it. So in calculating the pressure, we have here our formula, which is P is equal to force over area. So since we have our force, which is the weight, or the 539 newtons, we can use this as the force, or the F. So since the formula is P is equal to F over A, then F, which is force, which is we have here, so this is 539 Newton, over area is 0.028 meter per second. Then we will divide it. So 539 divided by 0.028 is equal to 19,250. Then we will just simply put N per meter squared. So this is the answer in finding the pressure. This answer we can substitute it with PA. Then we will discuss it further about pascals, or the pressures unit. So this can be also written in 19,250 PA. So this is the unit for pressure. Then we will proceed to another slide. So to define the pressure of a specific point, the pressure is defined as the force dF exerted by a fluid over an infinitesimal element of area dA. So this is the figure, or the formula. I will just write it for you to able to see it clearly. So this is pressure, or P is equal to dF over dA. Don't worry, this is just a similar figure with the formula here. Then we will proceed to the next slide. So as a unit of pressure is the Pascal. So the PA, which is, we have here the answer to our previous example. So 1 PA is equivalent to 1 Newton per meter per second. So let's proceed. By the way, this is Blaise Pascal. This is his picture. So the pressure exerted by one body on another depends on two factors. The first factor is the magnitude of the force applied. Then, to increase the pressure applied to any object increases the amount of force applied. So if you exert additional force to a certain object, you will basically add more pressure to it. The next is, greater the force, greater would be the pressure applied. Of course, if you apply a greater force, then you will have you will exert, you will penetrate more pressure to that object, to that certain object. The next is the reason this effect happens because pressure varies directly with force. So the pressure is directly proportional to your force, or to your force exerted. Then let's proceed. So the second variable is the area over which force is applied. So since to get the pressure is we need to consider the force and the area. So the area of contact between two object. So in our example, we talk about the area which ang object is na occupy. Then by that, area is another variable that we need to consider. The next is you can increase pressure due to the same force by reducing the amount of area over which force is acting. Then, of course, if there's a large area or area occupying that object, that simply means na ang pressure is dako. Then if that object is occupying only little or a little area, gamerang area, that means nga ang anang object is gamera pud ang force na iyan na apply or for pressure nga iyang gi-apply. The next, we will talk about the applications of pressure in daily life. So we have two cases. First case is a small area resulting in greater force, greater pressure. Then case 2 is large area resulting in a smaller pressure. So this is the application of the pressure in daily life. So in this part, it talks about in a vacuum, because if there's a smaller area, that means na ay mas dako ang pressure, just like anang hose or water hose. If gamay ang iyang opening, that means mas dako ang pressure. That's why anang mga firefighters magamit sila og hose nga gamay, so that ang pressure sa tubig mo exceed or mo abot siya sa taas. Then second case is if there's a large area will result to a smaller pressure. So just like dams nga or open sea, that means na ang water is gamay ra or pressure is gamay ra. Okay, there's a huge space. Pero kung mag-talk about a certain object which is exerting a force or pressure towards the certain area, magvary ang kadakon o ang force nga gi-apply. Now that we discussed the lesson, we will now proceed in the activity. So I have here an activity. You need to answer this. So here's the problem. So a truck is crossing a bridge. The total area of the truck is 15.5 square meter, weighing 756 kilogram. Then first we need to calculate the weight of the truck. Then we need to calculate the pressure the truck is applying to the bridge. So since you all know the procedures in getting the pressure, we will apply this in getting or in calculating the weight of the truck and also the pressure of the truck applying to the bridge. So you just comment your answers in the comment box section so that I can provide the correct answers. So that is all about pressures in week 5 of the General Physics 1 in grade 12. So the further lessons or further discussion will be elaborated in the next reporter in this certain module.